Hi everyone, I'm Johnny, producer of Telecoms World Asia, and welcome to our latest webinar on edge computing. We are joined by a great panel today featuring IEEE, and they will be joined alongside Saudi Telecom, Alibaba, Telstra, and Google Cloud. The session will be moderated by Ira Tan of IEEE. For any questions, please post them in the Q&A icon you can see below at the bottom of your screen. And without further ado, I will pass over to Ira, who will begin this webinar. Thank you.
Thank you, Johnny. Good morning, good afternoon, and good evening to everybody. A virtual warm welcome to everyone joining this webinar. My name is Ira Tan, and I'm the Regional Manager at IEEE Asia Pacific. I'm very honored to be the moderator for this very interesting webinar on moving telcos to the edge. I believe many of the engineers that's listening in will be very familiar with IEEE, which stands for the Institute of Electrical and Electronics Engineers. We are the world's largest technical professional organization dedicated to serving the practicing engineers. We have more than 420,000 members globally and publish nearly a third of the world's technical literature in electrical engineering, computer science, and electronics. Our publications include approximately about 200 journals and proceedings from over 1,800 annual technical conferences. We also have a portfolio of over 1,200 active standards that underpin many of today's leading technologies, such as Wi-Fi. Many of the engineers, they rely on IEEE's content to stay up to date on the hottest technology trends, including edge computing, 5G, which we will be discussing at today's webinar. And joining us at this webinar today is a list of very fine panelists who are also experts in the area of edge computing. And they will be sharing with you their thoughts from business models perspective and also the software architect's perspective. The panelists that we have lined up for you includes Mr. Yao Yu, who is the General Manager at Alibaba, Mr. Sebastian Barros, who is the Regional Head for Southeast Asia at Google Cloud, Mr. Saad Sheikh, who is the Chief Architect at Saudi Telecom Company, and of course, finally, Mr. Simon Delord, who is the Principal Architect at Telstra Australia. So before we go into the details of today's webinar, I would like to invite the panelists to actually do a very brief introduction about themselves, and then we'll deep dive into the discussion. Perhaps we could start with Saad.
Yeah, sure. First of all, thanks for having me. My name is Saad Sheikh, and I work as the Chief Architect within Infrastructure Planning and Architecture Design team of STC. My team main role here is to define, design, and deploy the common shared programmable and shared infrastructure. So everything that's come in the infrastructure, and we all know, it's coming with the modern era technology blocks, all this cloud, NFV, 5G, edge. So this is, what I have been looking for here.
Thank you, Saad. Sebastian?
Yes, thank you very much, first of all, for this invitation. My name is Sebastian Barros. I'm the Regional Head for Telco Sales at Google Cloud for the Southeast Asia region. I'm based in Malaysia. I've been 20 years in the industry. Before I was working for Ericsson, and before that I was also working for one of the leading operators in South America. My role in in Google Cloud today is actually to help telcos actually to transition from their existing networks, right, to more cloud native type of technologies, right? And this encompasses, of course, AI power analytics, their VM migration, their 5G microservice architecture, and also edge. And in edge, I'm also leading our Asia Pacific task force together with our global team, right, to actually accelerate the adoption of edge technologies in partnership with all the telcos in this market, right? So very happy to be here.
Thank you, Sebastian. Simon?
Thanks, Ira. So thanks for having me as part of the panel for discussion tonight. My name is Simon Delord. I work for Telstra. and I'm a principal architect looking after the largest business enterprise for Telstra, basically the largest account. I'm part of a group of people in there, and I look essentially after the data center piece of that, as well as the strategy for software-defined networking for these customers. That includes the edge computing component, basically.
Thank you, Simon. What about Yao?
Hi everyone, I'm Yao. Thank you for having me on this panel. So I look after the international business and product for one of the product division at Alibaba Cloud, specifically around CDN, edge computing, video cloud, and cloud communications. Right. So on that front, we work with a lot of internet companies on one side and a lot of telco partners on the other side, all around the globe. And it brings me great pleasure to have the opportunity to share with everyone what we think is the future of edge computing.
Right. And I think, all of you has that kind of expertise that we hope that during this discussion, you could all share with us all your thoughts with regard to the edge computing and telco that's in the market. So let's start on the discussion point, which today's webinar, we are talking about moving telcos to the edge. So with the 5G already deployed in some of the countries, the emergence of the IoT devices and greater global wireless access and the role of edge computing to the core telco network models is rising significantly across the multitude of areas, including latency, data, network, virtualization, and bandwidth. Edge is actually amplifying opportunities for service providers across the entire telco ecosystem. The discussion that we're going to have today, we hope to cover a few points, which is fundamental advantage of edge computing, looking at improvements to connectivity and infrastructure, and then we'll discuss on where the value is. So to this point, I would like to pose a very important question to the panel, which is how will edge computing accelerate 5G growth, business growth? Shall we start with Sebastian? What's your thoughts on this?
Yeah. I think it's a very important question, maybe to set the discussion and the tone, right? In my perspective, right, we cannot understand the real value of 5G without incorporating edge as a central point for the business and technology discussions, right? And also strategy. Despite today we are in a very early stage of adoption of 5G. I think if you see worldwide, we are essentially on the 5G non-standalone standard, which really focuses very much on really fast speed, right? And you can see that Telstra, South Korea operators are showing extremely fast speeds, right? What is going to happen in the next 24 months is actually a very different picture. It's going to be actually something very unique. And I think this will come with the hand of 5G standalone standard that is bringing, first of all, ultra reliable, low latency communication, a microservice architecture, and also is expanding the telco network towards a more open and distributed architecture, right? If I try to break this a little bit more, if I look at 5G today, right, we have around 80 telcos who have already launched 5G. We have more than 60 million 5G subscribers. And actually, analysts expect that 5G will be the fastest technology ever to reach 1 billion users by 2022, right? Now, edge brings a massive value to 5G. It opens the door for telcos to access the Industry 4.0 segment with a new breed of applications, right? One of the very famous studies I've seen is from Ericsson and Arthur de Little that estimate that the business value of 5G edge in the industry segment will be around $1.5 trillion by 2030. And interestingly, in the same report, you can see that half of that value could be potentially be addressed by telcos. Now, one more point that is important, right, is where is the link between 5G and edge, right? The link is that by expanding the reach of applications from the data center, the telco regional data center, or from the hyperscale cloud to the base station site, right, extremely close to the user or to the machine, right, we can develop a new breed of ultra reliable performance and ultra low latency use cases for Industry 4.0. And many cases are already in use, like remote industrial operations, unmanned vehicles like driverless cars, driverless trucks, robotics, remote manufacturing, remote healthcare, unmanned drones delivery, and many other modes, right? Now, for this to happen, right, we will need actually to put an edge, right, in those far locations that allow us to have extremely real-time network performance experience, right? I mean, 5 milliseconds, something that we cannot really achieve today, neither with cloud, neither with telco regional data centers, right? And interestingly enough, we will need to host this part of these applications, right? These business critical applications at the farthest edge location, right? And those applications will need to have capabilities to orchestrate between network resources and applications all the way to regional data centers and public cloud, right? Now, this will not happen from overnight. It will be, of course, an evolution. But what I really want to highlight that actually 5G and Edge tightly coupled can bring to telcos a completely new set of business and monetization streams that we didn't really have before, right?
Absolutely, and I think, you know, this 5G and edge computing, it does come together, and there I see there's a huge acceleration over there. Yao, would you like to comment on that? And I think you have talked about cloud computing in your previous TWA webinar, and you were talking about moving from cloud to edge and how 5G is accelerating on that. And right now, I'm asking you how edge computing will accelerate 5G growth.
You know, during the last webinar, when I was talking about this, I was talking about how there's this pendulum swing that's going on.
Exactly, I heard.
You know, kind of from back in the 50s, 60s, and 70s, we had all these mainframes, right? And there were these huge systems that still power our banks today. And you know, we built all these centralized systems. And then in the 80s and 90s, a lot of that moved out to the client server model, right? So that a lot of that moved to the homes, to the offices, and they kind of move out right to the edge of the network, if you will. And then subsequently with cloud computing and the mobile revolution, right? A lot of that, you know, from 2005, a lot of that moved into giant data centers, right? So, you know, all the different cloud service providers, including ourselves, started building huge data centers, right? And it was interesting because it became a situation as the internet became more evolved, connectivity became better. Like it was possible to centralize a lot of these and then be able to serve users like around the world, right? From a centralized, you know, a lot of people think of it as, you know, the power plant, right? Of data and compute, and you can storage, and you can generate a lot of that at the centralized location and serve users around the globe, right? Pretty much all of that. And then I think what we have seen, and I remember this 2 years back, I had a friend who actually came, like he worked at an autonomous vehicle company in Texas, right? And out of the blue, he contacted me and asked me, and that was 2 years ago. He actually asked me like, where can I buy a 5G tower? I was like, oh, okay, that's an interesting question. Like 2 years ago, nobody asked me like, you know, a lot of people talking about 5G. Nobody was asking to buy a tower and set it up. And I was asking him like, yeah, dude, you're not in like the telco industry, right? You are basically building autonomous vehicles. Like, why do you need a 5G tower? Like, basically he worked with all the networks in US and the latency was just not good enough for autonomous driving, right? They needed to be able to process all the images in near real time. And they wanted to experiment with setting up their own tower, their own private network. I was like, wow, okay, that's a severe, like, that's a heavy investment, right? And then, you know, I gave him some ideas how to go about it, but it gives you a glimpse of what is possible. I think what we have in this situation is that as a lot of that data generation, a lot of the use cases move to the edge, a lot of the data generation happens at the edge, a lot of the processing needs to happen at the edge. What we are seeing again is a lot of that compute storage and the data processing is moving out to the edge, right? That's one way to think about it. The other way I think about this is that if you look at kind of all the compute, as our processors get faster and faster and faster, they become more powerful, right? And what ends up happening is that, you know, I look at the world of CDN, which is, you know, one of the products that I deal with. And the word CDN, basically, why do we, you know, when in the 2000s, right, when Akamai started with that whole idea in the 90s, when we had the internet, why did we have CDN, right? The concept was to cache all the content out at the edge, so that you, as a user at the end handset, you get your content faster, right? So let's say you're sitting in Malaysia, like Sebastian, you pull the content directly from in Malaysia, rather than having to go to, let's say, the US, right, where the YouTube server, origin server might be, right? And so like that gives you a much better experience. The same thing, I believe, will happen with applications, right, which is the two-way interactivity, right? So instead of the 50 milliseconds or the 500 milliseconds, you're looking at the 5 milliseconds. And that improvement in the application performance, I think, will make a dramatic difference in what the user experience will be, and all of that will be powered by edge computing.
Yeah, very interesting sharing on your story, and I think you have actually kind of captured the essence of 5G and edge computing. What about Syed and Simon from the software architecture point of view? Would you like to comment on how edge computing accelerate 5G growth?
Yes,
Yeah,
I think it's
absolutely.
very.
Okay.
Sorry,
Simon, maybe Simon, you can go ahead first. I will take the last slot.
Was it for me or was it for no? Who? The one in Australia
Simon,
or the one in Riyadh? Okay,
yeah,
okay.
Simon, you can
All
start.
right.
Yeah.
All right. No, so thanks. I think what you and Sebastian have said is very interesting in terms of the have applications that are microservices based. So I think from an edge compute perspective, you need to have a different way of architecting those applications to take the benefit of the distribution of the infrastructure below it. I'd like to expand on that. I think from purely, and that's my personal view on it. It may not reflect my my employer's view, wider view on those ones. But I think the open source ecosystem is very relevant for us in terms of driving benefits and new streams of income, because we can actually start build and play like Lego, Lego cubes type of approach to build whatever we need to do for our customer. So in my particular case, for my customer, that's typically the sort of things we do. So today, the possibility to have any type of x86 platform community hardware on site where I can deploy either virtual network functions as opposed to having to deploy physical hardware, but also I can enhance that with VMs or containers, potentially to do any type of, IoT integration, machine learning, and like inferencing of the data closer to the edge, like you said. I think that's very beneficial. Again, but I would say that I think in that regard, the open source environment is of capital importance for carriers to succeed as a way of being able to differentiate. My customers may not have the same need as, the customers in Riyadh. I'm sure they have something similar, but that I can tweak the solution the way I want is of big importance to me, I think.
Right. Saad?
Yeah, I agree with the rest of the guys, but obviously I have some different point of view on this. You see, first of all, we all know the relation between 5G and edge is very symbiotic, and we have seen across the region, most of the T1 and T2 operators aligning their 5G strategies linked closely with the edge, right? And similarly, on the edge side, we, frankly speaking, most of the application and use cases that require high-speed connectivity, and that is certainly something which is strongly dependent on 5G, right? But really to make sense of the opportunities created by edge using the 5G, it's very important first we understand that the new era of future networks, we have to build with a new paradigm or a new principles, right? And out of it, like the concept of the distributed cloud, the whole industry is shifting, and we find that the putting all application in the center is not serving the end user requirements, right? Similarly, the cloud native, yes, it is true that with 5G, we are starting with SA, but we all know that on the edge, most of the applications are already containerized and ready. So as an operator, for sure, exploring edge, it is not only benefit us to achieve some quick wins with the 5G, but also to really experiment with the new ways to manage our applications, to explore how we can serve the developers. Actually, it's open a real horizon for the telcos, and I guess that is why it's very pivotal that we should invest on the edge and start it from now. Yeah.
Yeah, I think this is a very good point, sir, that you bring out, which actually brings me to my kind of following up question regarding growth and opportunity. Where is the value for telco and CSPs in the edge computing ecosystem? In other words, how will the edge move telcos up into the value chain? Would anybody like to comment on that? Yao?
Sure. Yeah, if you want to answer.
Go ahead, Sebastian.
Sure, I think if you ask me, edge, the problem we're going to have, or the challenge we're going to have as an industry with edge, is not so much on technology. I'm not worried about technology. We, as I think all of us agree, we see a great benefit of bringing cloud native technologies, open source architectures towards telco, right? And that's great, and I think has been very well adopted by 3GPP, ETSI, and many other standards that actually now, and telcos have been actually very progressive in that sense. I don't think technology will be an issue. I think the real challenge for everyone will be to unleash the value of 5G. We will need to work in an ecosystem. We will need to build an ecosystem. And interestingly enough, if you look at the ecosystem today, nobody owns all the pieces, right? You have the telcos who owns the edge. They have the technology. They have actually that extremely capillary network, right? If I look at countries like Indonesia, maybe you have 100,000 sites, right, that could be benefited from edge. You have cloud providers like AliCloud, like AWS, like Google Cloud, that could actually start moving some of the enterprise workloads to that edge in order to benefit from that performance. We need the developers, because without developers, who is going to create those amazing new breed of applications? But also we need enterprises, right? I mean, enterprises are still not in Industry 4.0. I would say if we look at, especially in markets like Southeast Asia, right, many enterprises are, I would say, that in maybe Industry 1.0, right? So for them to go on to speak to a manufacturer and say, well, you know, now you have an opportunity to automate your industry by leveraging on 5G edge, right? It's quite a big business jump, right? It's a leapfrog jump. Then you have the regulators. So don't forget about that. Oil and gas industry, manufacturing industries are heavily regulated, right? So I think one of the things that we need to think about is how, as an industry, we're going to drive those business resolutions to make sure that we can monetize edge and really drive growth, right, for everyone, right? Which I think is very, very beneficial for the society, right? I think that's something that we need to work more, and we need to find ways that we could facilitate this, right? And I think I see, of course, here the governments will need to play a big role. And I think maybe in some markets I've seen very good initiatives, like in Singapore, for instance, they have Industry 4.0 initiatives run by the government themselves. China, I think, also has been leading on Industry 4.0's development. We also have Australian government being very progressive in that sense, right? And that helps actually to bring everyone into the same picture, right? And try to really progress towards an outcome-based, relationship.
Mm-hmm. Okay.
You know, the interesting thing, I think, is that with edge computing, part of the premise of edge computing is that the network becomes a lot more important, right? Because, if you look at cloud computing, we used to centralize everything. Once you take that and decentralize it up, and you move it to the edge, then how you move the load around the edge becomes extremely important. And that whole network is essentially where telcos are very, very good at, right? The building of the network and running of the network and being able to move the loads around the network is essentially what telcos are very excellent at, right? And I foresee in the future, because we really see this in some of the experiments that we did together with partners and enterprise on one side, as well as our telco partners on the other side, where basically there's just no way we could do what we want to do with edge computing without close partnership with our telco partners, right? In this case, like in the case of Alibaba Cloud, a lot of what we were experimenting with was in China. And there were a whole bunch of use cases that we were experimenting with. Like, for instance, we're looking at cloud gaming, right? Where we could basically run you look at a lot of the games today, they are either installed on the mobile or they're installed on your desktop, right? And moving this into the cloud by using a 5G environment, you have very low latency. Basically, everybody can play multiplayer games, right? Using the very low latency 5G network, but all that compute happens right at the edge. And this is a compute intensive scenario, right? Another part is, another example that we've been experimenting with is how to move the live streaming, transcoding part of it, which is also a compute intensive workload out to the edge, right? Closer to where the stream is being recorded and also being distributed down to the viewers, right? And so like you can move all that out to the edge, the experience is so much better. But in order to do that, we essentially had to work very closely with the telco partners in order to really move all these out to the edge into really small installations right at the very edge of the network, much closer to the homes and the offices, right? And the other scenarios we've been experimenting with is in the manufacturing environment, right? A lot of that manufacturing, sensor processing, video processing, a lot of that compute, and how do we move that right into the manufacturing environment as close to the factory setting as possible. And we also see customers asking for that, right? And when customers are asking to move that workload out, on almost all the cases, they were very, very specific in terms of like localities. Like I need to be, these are where my workloads are happening. I need to move these out, right, to the edge of the network. And then we have to work very closely with our telco partners to figure out how to move those right to the edge, right? And this is part of that whole experimentation. One of the most interesting thing about this, and we talked about this all the time, is we were always speculating like, what will be the killer app, right? What will be the app that will move all these out and launch the era of edge computing? So far, we haven't had a very good guess at that. There were a lot of bets on it, but nobody has a good answer. But it's interesting to see what people come up with. But we do see increasingly more and more folks are looking at how to move this to the edge. One of the things that Sebastian touched on that I thought was extremely interesting is also we are starting to see standards group coming up, right? Where they're looking at how do you standardize some of the computer workload so that, let's say I'm on this edge compute environment, I can move to another edge compute environment without having to overhaul my entire architecture, without having to rewrite all the code. And I think this touches on some of what Simon has also mentioned in terms of the open source movement around this. And I think that will be extremely important and extremely crucial for us to watch how that evolves.
If I can jump back on something, I think it's interesting what you mentioned about the partnership, because there's a big risk as well with this type of approach that basically anyone can go and do an overlay solution, right? So as a carrier, you don't really want to be doing just the plumbing anymore. So I think you're right. Having specific applications you can bring down to the end users that are using the strengths of the network you have, that would be one differentiation. I think another point as well is we may not need some specific killer apps. There's some operations today that are quite difficult for carriers to do in terms of automation, in terms of deployment, that can still be done by using the edge compute. So there's actually a strong basis to build upon already. So we may not need to wait for a killer app. We already have ways for us I can only speak about my environment for some customers where we actually do that for them today in much better ways than we would have done in the past, by just using some specific software we developed to the deployment of some specific network application, network functions at the edge. But yes, I agree that if you were doing only that, if you're only doing some sort of carrier edge capability, then the carriers will going to be struggling on this one, because enterprise can start deploying those environments themselves basically as an over the top.
Just to add on this, I think the key point here is because of the diversity of the ecosystem, right? How to generate the real value. I think still we see an effort, especially like some hyperscalers want to cannibalize the market, and then operators want to build something on their own. So it's very important to create the real value chain, that we focus on the real differentiation and synergy. I think Zhao have rightly said that telcos have some obviously advantage. For example, they own the edge. They have better experience to manage the end user connectivity. and especially on the international and interoperable frameworks like the roaming, right? All of these initiatives, they have advantage. On most of it, I think as the edge is becoming a reality, the concept of the how to place the workloads, how to optimize it, right? How to handle the failures. I think this is definitely, you know, one direction. But on the other hand, we really need to see that how to experiment with the with some of the, I should say, lapses, right? For example, we all know that in the edge enterprise value chain, telcos are not well integrated compared to the hyperscalers. And then we know, I think Simon has raised a very good point about the automation and the manageability, because we still see, you know, that it's taking a lot of time, and especially when we talk about the services, you know, creating services and tear down the services on the fly. This is some domain I think we really need to bring the right partners on board to place the right mix to create the value for the whole industry. Yeah, so this is my take on this.
Mm-hmm. I think that's a very interesting share from the panelists. We talked a lot about the edge ecosystem and creating many more opportunities surrounding networking and perhaps in the area of data. What about virtualization and cloud? Do you see also opportunities in that area per se? I think in this unprecedented time that we're in, virtualization is so critical. So I believe there is a great opportunity, but perhaps you could, you want to elaborate on this point?
Yeah, maybe I will start because, you know, this is why I think go
your area.
Yeah, actually, how we see it, you know, that before the edge movement really takes momentum, most of the operators have already invested heavily on this cloud, NFV, and building the data platforms, standardize the data modeling, how they will use or capitalize the data. So it's quite natural that we want to build something for the edge, which is to take the you know, benefits of the experience and investment what we have done so far, right? We have seen, for example, we even within the ITC Linux Foundation, the reference architectures for edge are coming that are, for example, closely stitched with the cloud, with the NFV, all those aspects, right? However, the more important part here is this, that we can really create the new opportunities in this domain if as an operator community take more roles and responsibilities. I just want to share, for example, even within the GSMA, we have taken, I think, quite a lot of time, more than 6 months, to define the principles, you know, to set the right, because you see in edge, it's for us, it's not like a cattle ranch. We find a lot of solutions which we have to deploy and manage in a very constrained environment, right? So the thing is that we really need to see in terms of the verticals, and also we need to see, I mean, in terms of the partnerships, right? This will, and what will be the role, who will steer it, right? In other words, an operator community, we need to really define to lead this common shared or viewpoint, because this will ultimately define, you know, because ultimately we need to see if we are building the clouds, can we scale across the geographical boundaries? Can we standardize a global framework? So this is, I think, this is the tricky and the more important points that will ultimately unleash the opportunities or edge compared to like association with the cloud and this. So yeah, this is how we see it, you know, the industry moving forward.
Thanks for that. Can I say my piece on this one? Is that
Sure.
okay? Okay?
Of course, Simon.
So I think the benefit of edge compute for telco and CSP is really you can start developing services that you would normally not have done before, because everything is now standing on standardized compute. You're no longer offering just network services. You can start getting into the sort of things that we were never able to do before. So for example, we can get into the IoT space by deploying some capabilities at the edge to inference learning. So there's a lot of things actually you can bring that in combination with a hyperscaler. So you're no longer under the ecosystem, you now become part of the ecosystem. So those type of footprint that the hyperscalers won't have, but same as carriers won't have this type of capabilities in the data centers. You can now benefit from each other. So you still have the main function sitting in your core cloud environment. And then as an edge compute provider, you can also deploy any type of ecosystem you want. So there's nothing stopping you from deploying an AWS, a Google Cloud, or an Azure solution at this edge, all three of them at the same time if you wanted to, running in containers, for example, to do specific functions for your end user. In my case, for example, the IoT, we can do that and we use that, right? So that means those type of capabilities that we would not have done previously, we would have been stuck with just switching and routing and a bit of firewalling. We can start now expanding more into the application space, and we can actually offer a set of fully integrated capabilities that when the end user goes into his Google Cloud console to do something, the capabilities can fully automated into the network of the provider at the edge, right? So the guy doesn't even realize he's not working on the Google Cloud platform, he's still in the Google Cloud console, but still working on something that belongs to the carrier. And normally that would have been the other way around, right? So I think it's a great possibility for us. Again, I would like to reiterate that I think this is only possible if you go down the open source path. If you're going down the specific vendor capabilities, then it's pretty likely that's not going to work like that. But if you're able to develop your own ecosystem in this environment, I think there's massive benefits to be seen in there. Voilà, that's it.
Yeah, I think maybe I can comment on Simon's views. I think yeah, he's spot on. I think if you ask me, Edge has more to do with cloud native capabilities rather than virtualization. Of course, I mean, most telcos have moved from having a single stack to NFVI, and NFVI was kind of a way to decouple the hardware from software, right? But if you see NFVI help telcos to reach certain point, but when you look at 5G architecture, if you really want to unleash the value, you actually need to kind of take a leapfrog step to cloud-based technologies. And when I say cloud-based technologies, essentially you need to think your network as a set of microservices that can be deployed in a service mesh architecture. So you don't really care if you are running that microservice in a container on-prem, in Google Cloud, in AWS. And secondly, you have the ability to orchestrate that microservice, that application that has been converted into microservice piece, all the way from edge, if you need, because you might not need, but if you need to put part of that application at the edge, you might have that ability. And I think Simon gave a good example on AI, and I think was one question from the guest. AI applied to the edge, right? So all of a sudden now you can run, for instance, edge TPU, which means you can do AI inferencing models at the edge, right? Maybe because you need some very fast performing vision analytics, right? And that can be done in a split of seconds, right? You can just deploy a new machine that requires that capability at the edge, right? Secondly, I think also Simon mentioned something that, okay, it's my personal vision, right? Not necessarily Google, but I think if you think about the way that edge will make sense to be developed is cloud providers will never have the capillarity to go and invest on 100,000 locations in a single country. But it could make sense that at some point when technologies are aligned, right, and we are talking the same language, right? We're talking the Kubernetes language, we're talking the Istio language, right? Open source language. Telstra, for instance, can tell me, well, Google, I have these edge locations where I have capacity, compute and storage capacity. And I would like to actually link it back to your GCP console as one zone. And you know, guys, if you want, you can resell part of this or offer it to some of your enterprises, or actually, I want to use it for my own application purposes. I think that's kind of of course, a vision, but I think that's probably where we need to reach this industry, right? So in my view, it's kind of a leapfrog step we need to take from virtualization to cloud native technologies. And I'm very happy to see that in 5G, and there's a whole movement around really adopting this to that extent, right? And I think that will be beneficial for everyone.
And Sebastian, it's not just a vision. You have things like the AWS Greengrass or the Azure IoT stack as well that are fully integrated into those type of distributions. I suspect Google would have something similar. So there's no reason, like this is, for at least for the IoT use case, that's something real, for example.
Yeah, exactly. I think of course each cloud provider is taking different philosophies, right? So you have For instance, yeah, AWS with Outposts, Google is more software-led with Anthos. But I think if you see, and if you read between the lines of what is happening, I think it's happening that, right? So in a way, we are trying to integrate Edge as a fundamental piece of a distributed cloud that allows you to create a microservice mesh, right? Regardless if you're talking on-prem, regional data centers, it doesn't really matter. You will use it depending on the type of application.
And something the carriers would never have been able to do before. So actually, in that regard, it's brand new services for us to be able to.
Exactly. And maybe one point, right, since I got very excited on this point, is not also something that cloud providers can do. And I think this is important. I mean, sometimes many people see telcos and cloud providers in a kind of a enemy situation. I don't think it's really the point in Edge. As a cloud provider, you will never be able to reach more than maybe 60 milliseconds, 40 milliseconds for an application to work. So unless I'm find a way to work with a telco, right, that's the only way for me to go towards maybe minus or below 10 milliseconds, right? So it's not a capability that I also have as a cloud provider or the operator has as itself, right? So it's very symbiotic relationship, I feel.
The other use case being survivability, so a lot of survivability for some applications for failure or whatever security measures they have, and then you cache the data, and once the communication comes back or whatever rules is applied to reestablish the communication, then you can send that back to the hyperscaler environment, basically. So there's a lot of complementarity, like Sebastian was saying, I think, on that.
So very interesting, which actually, the way the panelist has been describing, it talks about improvements to the connectivity and infrastructure. So my next question to all of you would be, are telcos or should telcos move away from the traditional infrastructure models in order to roll out greater edge infrastructure? I believe it's a yes, but perhaps you could share again your views regarding to moving away from traditional infrastructure. Yao, would you like to comment on this?
Yeah, I think I think that we all share a similar sentiment in terms of that this is a symbiotic relationship, right? I mentioned earlier, as when we have the entire edge computing framework, we need to move a lot of these workloads out, and that's not possible if that you cannot do that alone. Well, the cloud service providers, right? And the network itself is owned by the telcos, and I think that's where we have a lot of opportunities between the cloud service providers and the telcos to work together to deploy this edge, right? And I like the word that Sebastian is painting, which is that you can move this workload, whether it's on-prem, whether it's back in centralized cloud, whether it's right at the edge and across different nations, across different telcos. It's an open world where the enterprise deploy once, it rolls out to the edge around the world and moves a lot of the compute workload right to the edge itself for the benefit of the users as well as the businesses, right? And I think this is kind of the vision that a lot of the cloud service providers as well as the telcos are working towards, right, to enable this, right? Because I was part of some of these standards body and discussion. Part of it was looking at how do you do all the bytecode compilation, right? And that's all about the software environment. Part of it was, how do you create all these virtualized containers and being able to shift it back and forth seamlessly without any human intervention, right? And what is interesting is that you look at the folks who are involved in the whole discussion. Red Hat was involved, for instance, right? They were the champions, the original champions, if you will, of the open source movement. There were cloud providers there, there were network providers there, there were telcos there. And you can see that everybody was building towards this vision. And I think that is where a lot of what the network and the telcos are working towards hand in hand together with the cloud service providers to deploy this edge infrastructure that's all encompassing, that allows you to shift all these loads seamlessly.
Okay, I think that kind of very much sum up the talk about the infrastructure of it. Now, I have a very interesting question that was posted on the Q&A, and I think Simon also touched on a very interesting point on security. which has not been largely being mentioned over here. This question is actually from Rob, and it's to Sebastian regarding your earlier your sharing on 5G. He says Sebastian mentioned that 5G will see a significant growth by 2022, with many manufacturers creating new devices to utilize this. From a security perspective, the introduction of 5G is increasing the threat landscape quite significantly due to a lack of consideration for security by design. How do telcos, CDNs, identify threats across such large and geographically dislocated networks? Any comment on that, Sebastian?
Super good question. I think that there are a few things that to have in mind when we talk about 5G security. First of all, definitely, I mean, you are actually increasing the endpoints, right? If I look at 4G, right, we're predominantly talking about 4G smartphones, right? When we talk about 5G, you're going to have a wide range of devices. Now, one thing I want to highlight about 5G, which I think is great, is that the security capabilities from 4G to 5G has been increased. And let me just share, for me, the 4 key things that are actually different, and that will help this. The first one is that the IMSI encryption is using a home network asymmetric key, right, to avoid the typical IMSI catcher. This was a potential issue in 4G, right? You have enhanced interconnect security. If you look at the standard, right, we have now a new network function called Security Edge Protection Proxy, where all the signaling traffic, right, which is going to be massive in 5G, across the operator is expected to transit through this proxy, right? You have new authentication frameworks that actually allows you to be much more secure. You have what they call the EAP, Extensible Authentication Protocol, that actually allows you to use different type of credentials besides the one that is commonly used in storing the SIM card. So since you're going to have many devices, right, you might actually need different type of authentication protocols than the typical ones we use in a SIM card. The algorithms are stronger. You have actually, the 5G has raised the security to 256 bits level, right, in order to mitigate, for instance, cryptanalysis. Now, on top of that, compared to when we developed 4G, you have actually the eruption of machine learning and artificial intelligence. So now you can actually manage billions of logs, right, coming from your firewall, from your devices, and from any other part of your networks, and analyze it in near real time, right? So I think even though the challenges will be definitely bigger, I also feel that 5G as a standard has actually enhanced the capabilities, and also operators have more tools now, especially with AI-powered analytics, to actually make sure that their networks are resilient, right? That's my view.
Great. Anybody want to add in on security?
I think that's really good, Sebastian. I think there's really 2 things. Again, there's like you have the infrastructure security side of things, because now you're distributing, you have computers all over the place, but you ask Google how they've managed to, harden the millions of servers basically in the environment. But you already have, again, the infrastructure hardening, and then you have the application hardening. And I think Sebastian did a great job at explaining how you would secure the application itself. Again, we need to reuse the rules we use for hardening the servers and infrastructure themselves. So the hardware, the type of operating system, the virtualization layer within those environments, to make sure that no one can actually access them. And then on the per application basis, be it IoT, 5G, whatever you want to use at the edge, or you harden those applications as well, right? So that's I don't think that's any different from what anyone would do in the data centers today anyway, except the scale of it, obviously. So that's where the point of the use of the AI and the way of being able to bring back all the relevant data, all the logs back to a central location for processing, and probably having some of the rules enforced at the edge for that would be beneficial.
Yeah, I just want to add on this. We know compared to the earlier versions, 3GPP, is focusing more on the security side on the 5G. So the first thing on the architecture side is well addressed. It's not, we all know, for cloud and open, people think that, maybe it's not well defined. So from the standard point of view is covered. On the other hand, when we talk about the edge and distributed cloud, we see this is the direction for the improved security. The first reason is to control the blast radius, right? We don't want there is only a central control of the security for your whole network. And once there is an issue there, and it can impact all. So I guess the other points guys already mentioned, but this is the way, right? The first thing is the distributed and focus on the 5G with the security, new security frameworks like NRF, all the API security, each layer we have now a very mature framework. But this is very true, right? Even with the Kubernetes, it is not, I will not say it's fully validated, but this is on the way. And I think as we are moving forward in 6 months, 9 months, I guess security is well addressed domain in this context.
Okay, right. Okay, and I think there's one more very interesting questions, which is very appropriate for the current environment that we're in, where mobile streaming has increased demand following this COVID-19 that we all are in. How critical will edge be in order to succeed in mobile streaming capacity? I mean, definitely there needs to be an increase. Everybody's working from home. So how would you comment that? How would edge actually help in terms of this?
I can jump in here and talk a little bit about this, because it was pretty interesting, because we when COVID-19 first break out, it was in China, right? And so in China, what happened, and I still remember quite clearly, what happened was that it happened shortly before Chinese New Year, Lunar New Year, in January, when they started shutting down in China, right? And they started, especially in Wuhan and Hubei province, they basically shut down the entire province. The reason why they did that before Chinese New Year is because Wuhan is a major transport hub. And so when people go back home, they will actually pass through, a lot of them will pass through Wuhan. And if you don't take action, the virus can spread very quickly across the country, and it will not be containable, right? And so that's why just before Chinese New Year, there was this massive shutdown, and the trains were just going through Wuhan without actually stopping, right? And so the people couldn't get off, and and people cannot get on, and the virus cannot spread. Shortly after that, a week after that, everybody came back online. They didn't go back to the office, but everybody came back online. And I remember the very first day when everybody came back online, because we run a very large network for all the live streaming, as well as, TikTok is Alibaba product. And people use, I'm not sure if you guys are familiar with TikTok, but TikTok is like Slack, right? It's very similar to Slack. You can do a lot of, it's like Teams. You can do a lot of live meetings on it, just like you're doing like we are using Zoom right now. And on that very first morning, when everybody went back to office, the entire network went down, right? Because suddenly you have 100 million people who are trying to start live streaming and medias, and they are all trying to like set up conferences at the same time, right? And then you have the schools and the teachers who are doing that at the same time, right? And that whole network basically just went down. And during that time, basically the teams, our teams in China basically deployed 100,000 servers, right? And it was quite interesting because you're not allowed to leave the house, yet you need to, at some point in time, all the physical hardware that is virtualized is fully used up. And you have to go in and deploy hardware, right? It's like, and you have to go and connect the lines, right? But you're not allowed to leave the house, you're not allowed to go to the data center, right? And so there was a whole bunch of work that was done in order to stand up the infrastructure very quickly to support kind of 100 million people, right, coming online. And 100,000 servers deployed in a matter of days takes a lot of work, let's put it this way. And then one of the things that we were looking at, so there was a lot of background. One of the things we were looking at, because of all this streaming that was happening, was how do we take that, right? It was all coming to certain major data centers and being processed and then moving out back to the provinces, right? One of the things we were looking at is how do we take that and try to do a lot of the processing as close as possible to the offices and the homes and the schools, right? And do all of that as close as down to the district level. So if you kind of look at it, it's like from the country to the province to the city, and then it breaks down to a lot of different districts. We'll try to move that as close as possible to the district, right? Because a lot of people who go to school, they don't travel across like long distances. It's all right in the district itself, right? So you can solve all that right at the district itself. You don't even need to, leave. The experience is much better, and you're not consuming huge amount of bandwidth, right? Just to haul it to some place and then bring it back over again, right? And so there was a lot of work that was happening during that time in order to shift all these right to the edge and a lot of the media processing right to the edge, so that all the mobile streaming is a lot smoother and the network is not being overloaded.
So in one way, increasing your capacity, you're utilizing edge computer to reach out to the locations that are really in need, and you're kind of like decentralizing it again. That's right. What pretty much you're doing.
Because a lot of that processing was actually still happening, in major centralized locations, right? The major data centers, if you will. If you look at it from a geographical point of view, it's all the major data centers. You look at every single cloud service providers, there are certain major locations where they have deployed. But when you do that, there's a lot of like packets flying back and forth, right? From the edge to the data center, from the home to the data center and back, right? And so, but at the same time, the entire network was being overloaded, right? And so how do you alleviate the load? One way is to move that out so that a lot of these stuff doesn't really need to fly across the province, doesn't really need to fly across the city. All that can be resolved right at the edge itself, right? Without having to leave the edge. And that was actually an interesting, experiment that needed to happen to, alleviate a lot of the network load that was happening at that time. Because there were other things that was happening in terms of like lowering all the streaming bandwidth, all the, the resolution, some of that helped. But, it was very interesting in this case, we are talking about edge computing. What you could actually do with edge computing to help enable that and reduce that network load, to enable better and smoother mobile streaming experience, to help everyone who's stuck at home to be able
one case I think it's very solid, and I think maybe good to get Simon and also Sadia view is SD-WAN, right? So even before the COVID, SD-WAN was kind of a very hot topic. I think coming to what Yao was talking about, building virtual private networks across office branches, right? At that time, well, nobody thought that we will be working completely remotely, right?
At home.
But now I can see that if you go one step further, you say, well, we will developing SD-WAN edges, right? Where essentially full companies can run, all the virtual meetings, all the work space, right, are becoming even more necessary, right? So I think it's something that I feel SD-WAN will have a kind of a big momentum now, and will also probably drive good opportunities at the edge, right?
I agree with that. And Simon, Saad, you definitely agree with that. Any point of views from your region you want to share?
Yeah, absolutely. As we see it, especially for the impacts on the video streaming and this, I think even before this crisis situation, we have seen, right, there is an exponential growth on the traffic. But what has really we have faced in this crisis time is that going forward, we cannot build or expand our networks using the traditional models, and even maybe the existing cloud models, right? Maybe we have to do it very fast, and we need to, just like as Simon mentioned, we have, the big proliferation of hyperscaler, whoever is available. There's a public cloud, there's a private cloud. So ultimately, the concept of edge, the federation of the whole solution. And the most importantly, as we see, that to do some advanced use cases, once you break out the edge, then we have to see, through the video, the advanced use cases, and then address the security at the edge. I think this is really, something which through the video streaming and some use cases we can focus on the edge. Yeah, thank you.
Yeah, sure. Simon, you want to add on this the statement.
I think you guys have you've done a fantastic job explaining that. The SD1 though is still a bit of a danger for telcos because that becomes a pure overlay play. So again,
Right.
so on the telco side of things, yes, we need to be aware of the SD1 and embrace it, but in ways that maybe complement what we do as opposed to get rid of the carrier if you want.
Okay, actually, we are pretty much on time, and I guess that kind of summarizes up our discussion point regarding moving telcos to the edge. I can feel the energy in the room. I took down a lot of notes. I learned a lot from all my panelists, and I'd like to thank you for your precious time and your valuable inputs. And also for the audience that's joined us, thank you for sitting with us for the 1 hour. I hope it's useful for you. So this kind of wraps up and summarizes our session, and I will hand it back to Johnny.
Thank you, Ira, and much appreciated to everybody else. A big thanks to Yao, Saad, Simon, and Sebastian for a great discussion.